Okay, so in this video, we will discuss how to compute the gradient field of a scalar. So we're now calling this a scalar field. Basically, for each x and y, you just have one answer, right? It's not a vector. So how do we compute the gradient? Well, you all should already know that because we've done that before. We just didn't call it a field, but it's just a collection of partial derivatives. So if you have a function of just two variables, this would be partial derivative with respect to x and partial derivative with respect to y, just arranged as a vector. That's it. So it'll take a scalar and output a vector. All right, so how do we actually take the partial derivative? So one thing that I want to point out is that whatever expression that is under the square root, you cannot break that apart. So you can't separate the square root into like square root of the first term plus the second term or something like that. That does not work. What are you supposed to do? So think of it as just some expression that is under the square root. Now, square root is the same as power 1/2. But whenever you have a power on the bottom, you can actually bring it to the top, right? So let me just, show one extra step. So you're going to get something like 5 divided by 3x squared plus 6y squared, and that is to the power 1/2. But when it's on the bottom, what we can do is take it to the top. So we're going to take that whole expression and move it to the top. When we do that, the power 1/2 becomes negative. So that's just basically definition of negative power. So here we got negative 1/2 right there. So what I've done so far, it does not mean that they took the derivative already. Some people think, oh, well, she's already done with the derivative. No, all I did is I just prepared my function, so it's going to be easier for me to take the derivative. And now let's go ahead and do that. Now let's take the derivative. Okay, so we're using the chain rule, and we are first concentrating on just taking the derivative with respect to x. Okay, so we got 5 times something, this whole something, to the power negative 1/2. So how do we take the derivative of that? Well, we take 5, then we bring this power down to the front. So that's going to become negative 1/2. Then we keep the same thing. So it's negative 1/2, the same thing, but to the power 1 less. So negative 1/2 subtract 1, that would be negative 3/2. Okay, so we're almost done, but we have to remember the chain rule. So the chain rule says, yes, well, you can treat this whole thing as a thing, but you have to multiply by this thing prime. Okay, so what is the derivative of 3x squared plus 6y squared with respect to x? Okay, so 3x squared, that becomes 6x, right, with respect to x. But what happens to 6y squared? It goes away because you add in something that doesn't have an x. So that's just going to disappear. Okay, so in a second, I'm going to make it prettier, but let's also do the derivative with respect to y. So again, we're going to have 3x squared plus 6y squared. Everything is going to be the same. But this time, we're going to multiply by the derivative of the inside with respect to y. So the first term will drop out and it becomes 0. Second term will become 12y. Okay. So now let's just simplify this. So what can we combine? Okay, so we can combine the 5, the negative 1/2, and also the 6x. But do not ever try to do anything with that middle term because you can't, because it's raised to the power negative 3/2. So negative 1/2 times 6, that's negative 3, times 5, that would be negative 15x. And then that whole thing will be raised to the power negative 3/2. And then I'm going to do the same thing here. So that's going to become 6 times 5, so negative 30y. And then 3x squared plus 6y squared would be to the negative 3/2. Okay, so that's the gradient. Let's check this out. So I am going to show you that I got it. Okay, this whole thing is negative 3/2. That's the first one. The second one is negative 30y times the same thing. So I'll just highlight this guy. And let's submit it and see what happens.